Hi everybody, we are going to talk about some different domain problems here. So the first problem we have is h of x equals x over the square root of x plus 3. And if I look at this situation, I see that I have a fraction, so I know that I can't have a 0 on the bottom of my fraction. And I also see that I have a square root inside of that denominator. And I also know that what's under the square root has to be positive. So if I were to take the whole situation and map the whole thing out, I know that x plus 3 has to be greater than 0. If the square root of x plus 3 was on the top of the fraction, then it would be greater than or equal to. Because he's on the bottom of the fraction, it can only be greater than because the fraction on the bottom, the denominator, can't actually equal 0. So when I subtract my 3 over, my domain in this case is x is greater than negative 3. I could write it like that, or I could write it as bracket negative 3 to infinity bracket, or I'm sorry, parentheses around both of those. The next situation that we have is k of x equaling the square root of 12 minus the absolute value of x. Well, I know that what is under my square root must be greater than or equal to 0. So when I solve this guy, I'm going to take what's under my square root, set it greater than or equal to 0. I'm going to pop over here and we'll work out this problem together. So 12 minus the absolute value of x is greater than or equal to 0. When I solve that for x, I'm going to add my absolute value of x to the other side. So I have 12 is greater than or equal to the absolute value of x. And then to solve that, what that means here is I can take my x and I can leave the symbol the same for the positive value, and then I can switch the symbol around for the negative value. All right, because the absolute value could either equal positive 12 or negative 12. Because of the inequality being inside here, we have to make sure that we switch the inequality for the negative value. So I know that x has to be less than or equal to 12, and x has to be greater than or equal to negative 12. And so that would be my domain. I could also write that as negative 12 is less than or equal to x, which is less than or equal to 12, as a compound inequality. I could also say bracket negative 12 to positive 12 bracket. Okay, I have two a little bit more simple domain problems. In this case, I have f of x equaling the square root of 9 minus 3x. Again, it's under the square root, so I know that what is underneath must be greater than or equal to 0. And so I have 9 minus 3x is greater than or equal to 0. And so when I subtract that, add that 3x over, I'll have 9 is greater than or equal to 3x. And when I divide my 3 off, I'll say that x is less than or equal to 3. Okay, and so I could write it as this. I could also say that, so x has to be less than or equal to 3, so that would be from negative infinity to positive 3, bracket around your 3, parentheses around your infinity symbol. That would be, in interval notation, a way to write that. And then lastly, I have x squared plus 3x on the bottom of my fraction here in g of x's function. So I'm again just going to take this. I know it is not allowed to equal 0. So I'm going to just figure out what x values will make that equal 0, and I'll know that those are not in my domain. So I have x squared plus 3x is equal to 0. I have a quadratic here. Both of these guys have x, so I'm going to factor an x out. So x plus 3 times x equals 0. And I'm going to set each one of those equal to 0. So 0 and negative 3 are not in my domain. So your domain here, you could write this a multitude of ways. We could say all reals, x cannot equal 0 or negative 3. I could say that we're going from negative infinity all the way to negative 3, not including negative 3, unioned with from negative 3 to 0, not including 0, union 0 to infinity parentheses. That would be interval notation for the domain of that problem. Okay? I hope all of this makes sense, everybody, and best of luck on solving your domain problems.